Hello students, a very good evening. In this session, we'll be looking at regular grammars along with the regular expressions. In the previous session, I have covered the regular expressions to represent regular languages, right? Now, we have another model which is regular grammar. Along with regular expression, we'll be also beginning regular grammars. Okay. Good evening, Mamta. So I hope everybody doing the homework questions that I have given at the end of each session. So we'll be continuing the same thing for all the sessions. So please try to comment below the video so that if any options or if any answers are wrong, I'll be replying to you. So to cross check. Fine. So in this session, I'll be focusing on what is the regular grammar. And then, to know the regular grammar, you should know the definition of what is the left linear grammar, what is right linear grammar, and then we'll be practicing simultaneously a regular expression and regular grammar. Then we'll have some practice questions at the end. Okay. Yeah, Tejas, good evening. Okay, first, what is grammar? I hope I have explained just one line definition in the beginning class. What is grammar? Yes, Mamata, I have replied to everyone. If any answers are wrong, I have replied today. Just cross check the answers, what are went wrong. I think only one person has given all options are correct, all questions are correct. So most of you have done correctly. One or two questions might went wrong, but just cross check. Fine. So what is a grammar? Before learning regular grammar, what is grammar? How many of you know the definition of a grammar? Grammar is the collection of 4 parameters, right? What are they? The definition of a grammar is collection of rules, or you can say collection of productions which helps us to generate the set of strings. So when you collect all the strings, we get a set. That set is called as a language. So every grammar which represents a language, right? So grammar is a collection of rules. The rules we can call as the productions. So here P represents the set of productions. Let's see what is grammar first. Here in this representation, S known as the start symbol. And this S belongs to variables, like V is nothing but here set of variables. Or you may call it as set of symbols or set of non-terminals. And T is a set of terminals. We always try to represent with the help of lowercase letters. Okay, P is the very important parameter, that is set of rules, or you can call it as set of productions. Rules or productions. Okay, there are various types of rules are there. We'll see them. Okay. So now what is regular grammar? So you understood what is a grammar? Grammar nothing but set of rules which collectively helps us to produce the strings, and when you collect all the strings, which actually represents a language. So grammar is nothing but it represents a language. It represents a language. So depends on the type of grammar that you use, which will represent a specific language. If you are going for regular grammar, it represents a regular language. It represents regular language. Now, there are various types of grammars. We will be learning slowly. There are various types of grammars. Before starting the regular grammar, so you have, grammars, many types. Grammars are various types, like you have regular grammar. In that regular grammar, we will be learning two types. They are, one is the left linear grammar, another one right linear grammar. And the second type of grammar we'll see slowly in the next chapter when we go for the context free grammars. There we'll be learning linear grammar also. So every grammar has different set of productions. Context free grammar. Likewise, you will be having context sensitive grammar, so this is a very big list, right? We don't learn all of them in the same chapter. We'll be looking at in different chapters. Unrestricted grammar, right? The most famous and important grammar is context free grammar. Okay, yeah, good evening Parth. Grammar is, okay, so again, what is grammar? Grammar is nothing but set of rules which collectively helps to produce the strings, and when you collect all the strings you will get a language. So grammar is nothing but a collection of rules. In the first introduction lecture only I have given a definition. Grammar nothing but collection of rules will help us to represent a language. So set of rules which will help us to represent a language. Okay, the definition is here only. Okay, grammar is set of rules which helps us to represent a language. Okay, now what is regular grammar? Okay, so you have a lot of types of grammars. And now what is regular grammar? This is the first time we are dealing with a grammar, right? So far we did not deal with any type of grammar, right? Now what is regular grammar? Here we will be understanding how the grammar looks like and how the grammar is restricted to form. So regular grammar, in the regular grammar, if you look at a grammar, it is set of rules, right? So how the rule is defined? The rule is defined as like there is left hand side and arrow and RHS, which implies the LHS derives RHS. So if anybody writing S derives AB, so S is the LHS and arrow that derives AB. So S is some set of symbols, it could be one or more, and right side you may have 0 or more symbols, right? So this LHS derives RHS. So how the LHS is written, how the RHS is written, that depends on what type of grammar that you are dealing. So I have just told that is there are various types of grammars. In all of them, the how you write LHS and RHS are going to be restricted, right? You may have a lot of rules, but each rule depends on the definition of a grammar. Now we need to understand what is regular grammar. So if you learn regular grammar, you will get to know how the LHS and RHS are going to be formed. So to know the regular grammar, you must know, because it is LLG or RLG. This grammar can be defined with the help of LLG or RLG. LLG means left linear grammar, RLG means right linear grammar. What is LLG? LLG means left linear grammar. So what is it? RLG means right linear grammar. So if you know the definition of these two grammars, that means you know what is regular grammar. So anytime you talk about the regular grammar, either use this grammar or use this grammar. Okay, do not mix the rules of these two. Remember that both are different definitions. If you want to know regular grammar, that grammar should be right linear grammar or it should be left linear grammar. It must satisfy at least one of them. Okay, let's start. What is LLG? So we have two types of grammars. One is left linear grammar. Another one is a right linear grammar. So linear grammars we'll learn later on, but we'll learn first regular grammar. And in this, how the LHS is going to be formed and how the RHS is going to be formed. In both of them, we are going to restrict both LHS and RHS. In both of them, LHS has the same rule. That is, it should be exactly one non-terminal. V means exactly one non-terminal. Arrow. But how the RHS is formed? LHS is exactly one non-terminal. How the RHS is formed? RHS you can write two ways. There are two types of rules in the RHS. One, it is left linear grammar. So if you want to write a non-terminal, what is non-terminal? So one of the symbol in the variables we call it is non-terminal. So it must be leftmost position. And later you can have any sequence of terminals. T star means any sequence of terminals. Or you can write OR or you can write slash. So this is called as bar or slash, you can say bar, that represents R. So now either you write this production or the production looks like in this rule. Now we have two forms to represent what is left linear grammar. If you want to see an example, just look at example to understand. The example, you may write S derives S, A, B, or S, or S, A, or B, C, D, and all these rules, all these productions are actually in these two forms only. Look at LHS is exactly one non-terminal. This rule is following this form, because S is the V and AB is nothing but T written twice. T square, you will be having AB, and S is there here because S followed by T power 0 is epsilon, and SA is here and BCD is here because T star means you can write T power 0, T power 1, T power 2, T power 3 and so on. This represents T power 3 because 3 terminals are there in the sequence. So this T star means any sequence of terminals. VT star means exactly one non-terminal followed by any sequence of terminals. So sequence could be 0, 1 or 2, that depends on your formation. Now this is one of the example for left linear grammar. And also here S is there, here no need to be S, you can write any other non-terminal also, right? If you have many non-terminals, you can write any non-terminal here. So V is a non-terminal, exactly one. Here V is also one non-terminal. Two non-terminals you can't write because here V power 1 only there, not V power 2. So this is LLG. Now what is RLG? RLG, LHS is the same, but RHS, if you want to write a non-terminal, that should be at the last, and before that any sequence of terminals. If this is not your production, then your production may contain only terminals. So see an example to understand. What is right linear grammar? So something like this, S derives AS or BS or epsilon. Now you see AS in this form, one terminal followed by one non-terminal. Here no need to be one terminal, it could be any number of terminals followed by one non-terminal, and epsilon is there in T power 0. Any sequence of terminals, there epsilon also can come. Even epsilon is not terminal, but epsilon represents empty string, you know that. So this is also called as null rule, because when the rule has no symbols, you can call it as null rule. So this is a null rule basically. Okay. So this is the definition of the LLG, and it is definition of RLG. Now let's go further practicing these two grammars. Okay. So now I write a grammar, just try to understand is it regular grammar or not. So first example is, suppose anybody writes S derives epsilon. Second example is S derives AB or epsilon. Third example is S derives S or B. Right. Fourth is S derives SA or BS. Of course, let's write B first. Okay. Now just look at this examples and try to answer it. Is it really regular grammar or not? Okay. S derives AS or SB or C. Seventh, S derives AA and A derives B. Okay, just look at each production in the grammar and find out what exactly each one. Yeah, I'm waiting for your answers. In case if you are able to understand the definition of the LLG and RLG. So first look at, is it LLG? If yes, write LLG. If it is RLG, write RLG. Then if any one of them is satisfied, definitely it is regular grammar. So answer three things: LLG, RLG and then regular grammar. If it is not LLG as well as not RLG, definitely it will not be regular grammar. Okay, let's answer it. We'll look into each example here. Yeah, first one is definitely LLG. So I'm just putting here, LLG satisfied, RLG satisfied. So definitely regular grammar satisfied. Okay, similarly answer for the second one. Second one is also same, and these two are exactly same, right? It is also LLG, RLG and then regular grammar. Okay, this one, only one non-terminal is there. So leftmost, then it is LLG, rightmost, then it is RLG. But this is also called as leftmost as well as rightmost. And this B is there in both of them. So these two rules are there in both of them. Remember that in both of them, that's why it is also LLG, it is also RLG, and it is also regular grammar, no doubt. And what about this one? The fourth one. And remember, the first, second, third, they're all satisfying both, remember. And a fourth one, it satisfies the LLG because non-terminal is there leftmost, but non-terminal is not there rightmost, remember that. So these two rules are there in LLG, but this rule is there in only in RLG, this rule is not there in RLG. That's why this grammar not RLG, remember. It is LLG and it is definitely not RLG, but it is regular grammar. Remember, it is regular grammar. To say regular grammar, no need to be both. It can be LLG, it can be RLG, or it can be both. But if it is only LLG, definitely it is regular grammar. And what about this? One non-terminal is there right side, rightmost. So this is RLG, but it is not LLG. Okay. And any one of them satisfied is regular grammar. And especially sixth one, I'm putting 3 star. So people might do the mistake as I was doing in the beginning of, when I was studying myself, I was actually doing the mistake for this because I did not understand the definition clearly. What is regular grammar? Okay, anybody? The sixth one, exactly, Tanuj is right. Sixth one, never, don't say both. See, if you want to say, when you say LLG, right, all the rules must satisfy LLG. If you say RLG, all the rules must satisfy RLG. Some rules are following RLG, some rules are following LLG. It's not going to be both, remember. So this grammar is neither LLG nor RLG. That is the reason we say not regular grammar. Directly you can say, or you can say it fails LLG, it fails RLG. Definitely it is going to fail now regular grammar. Okay, so one of the important example for you, those people who do not understand the rules, a definition of the regular grammar, just look at this. Don't ever follow some productions are in LLG, some productions are in RLG. You may ask, sir, why did you say then this are both? Because here all the rules are there in LLG, all the rules are there in RLG. That's why we said both. We did not say because of one production. See this one, this production is in LLG. This production is there in both of them. Still we did not say both. Okay, so very important. Now seventh, what is it? Now non-terminal is there right side, rightmost. So we say it is RLG. It cannot come under LLG. So it is just RLG. So LLG fails, but RLG yes. So regular grammar. Any one of them satisfies regular grammar. Now last one. Now see, S is alone. When it is only one non-terminal, right? And there is no terminal along with that, then that satisfies both the rules. And small a, only terminal is there. Only one non-terminal is there. That is the leftmost, that is the rightmost. And only terminal. So all the 4 rules are satisfying both LLG and RLG. Okay. 8, don't say just RLG, Mamata. It is also LLG because this S and A can act as leftmost because in that production, left only there, in that production only left. There are 3 productions here, not one. There are 3 productions here. All of them are LLG and also all of them are in RLG. So it is going to be both LLG and RLG. Clear? So when you look at these 8 examples, you should never confuse what is a regular grammar. Regular grammar is going to depend on LLG and RLG. If the grammar is going to satisfy LLG or RLG, then it is always regular. When will be not regular? If the grammar is neither LLG nor RLG, then the grammar is not regular. Okay? So this is one of the important point. The second important point is, even though grammar is not regular, it can generate regular language. Okay, so I'll give one example. Ninth one. This is definitely not a regular grammar. Why not a regular grammar? Any guess? Why this grammar is not regular? Because the production never contained 2 non-terminals in the RHS side, right? It always contained only one, that to leftmost or rightmost. right? Two non-terminals. Because of this is not a regular grammar, because we have written VT star only. We did not write VVT star. If you write VVT star, this can come. We did not have that rule, right? So now this is not regular grammar. We know that. So it is not LLG, not RLG. So it is not regular grammar. But it is not regular grammar. But the language generated by this grammar, it is not regular grammar. I'm writing clearly, but the language represented or generated by this grammar, language generated by this grammar is going to be regular. Can you see what is a language? If you want to generate a language, you always start with the start symbol. Start symbol always we mention here, right? By default. So if you look at what S generates whatever capital A followed by whatever capital B. So capital A does small a, capital B does small b. So language is AB. AB is only one string. It is the finite language. When the language is finite, it is always regular. When the language is finite, it is always regular, because that is the, we are going to learn anyhow, but this is one of the important point. You can write a regular expression for this, because that's AB itself is an expression, right? One string, right? You do not need any operator to represent. Of course, concatenation you may use it, but it is regular language. So one important point, even though grammar is not regular, it may represent a regular language. But when the grammar is regular, always it represents regular. Remember the point. If the grammar is regular, it always represents a regular language. If the grammar is not regular, it can represent anything. It may be regular, it may not be regular. That depends on what grammar, how do you write it. Okay. Fine. So by this point of time, you should know what is a regular grammar. Now we are going to look at what is the language generated by regular grammar along with expression. We will also write an expression how it represents. No, Tanush, impossible. There is no algorithm in the world, because non-regular grammar may not be convertible to regular grammar. Why? Non-regular grammar may not represent regular language. If really it is representing regular language, you may carefully convert, but that's not an algorithm. Okay, there is no algorithm in the world. You cannot convert arbitrary grammar into regular grammar. But what you can do, you can convert LLG to RLG, RLG to LLG. We have a finite automata conversion. In between them, you can convert to finite automata to get another type of grammar. You can convert LLG to RLG with the help of finite automata. You can convert RLG to LLG with the help of finite automata. But you can't convert any grammar into regular grammar. There is no algorithm. Okay, by understanding you may convert, but there is no algorithm. Fine. Okay, now let's practice. Identify the language generated by the following grammars. Okay, you can write expression now, because we know what is expression. Identify the language generated or represented by the following grammars. Okay, first one, S derives A, AB or epsilon. What is the language? The first simple grammar. What is the language? What are the strings are there in the language? How do you represent an expression? Okay, focus on all the things. What strings are there? Okay, and how do you write a language and how to represent an expression? Yeah, very simple. That's very simple. You can always write an expression because it's so easy. So easy. Language is epsilon A, AB. And what is an expression? Epsilon or A or AB. You can write expression or you can write a set. You decide how do you want to represent a language. You can represent using the set notation or you can write an expression. So both are equivalent notations. Okay. Second example. S derives A or B. Okay. Very simple grammar, which is very important to understand what is useful and what is not useful. That's why Tanuj. Nobody will explain what derives A. You should understand what is the language. What is the language? Here, language is just B. Here, this is called as a useless production. What is it called as? Useless production. Useless. Useless rule. Why? Because capital A derives nothing. It's not mentioned, right? You are calling that function, but that function is not defined, so there is no use of that function, so you can delete it. Clear? So very important, very important. Don't look for A, what is it? So look at that is going to be deleted in the simplification, and you should look at other rules. In case you have something like this, S derives yes A. What is the answer? Now same concept. Is there any possibility that you get a string? Is there any possibility that S can stop? Like main function calling main forever. Oh, don't Tanuj. It's going to be empty language because it can't generate even one string. Can you show me how it generates one string? I've written A plus, right? Can you help me one? Yeah, how do you stop? S A comes. Can you stop the S? Can you substitute S with epsilon or S with somebody else? No, right? So please don't do such mistakes. You might be looking at only one side, but look at whole grammar. Fine. So very, very important. Very easy grammars, but you should understand how to look at the grammar. Okay. Fourth, S derives AA or BB, and A derives epsilon, B derives epsilon. Okay. What is the approach always we follow? Our approach is very simple. You go from bottom to top, understand one by one. Like when you have a bigger project, you don't start with the main function. You learn modules, then go for the actual program. So bottom to top is the best approach. So first understand what B does, what A does, then put in the main thing. So S depends on A and B. By the time A and B will be known, so you can directly substitute them. So A and B are very simple, so I'm just speaking, they are deriving epsilon. So language nothing but L of S. L of S nothing but what A does, dot A plus what B does. Bar is also called as actually, it's a R. R means plus. So what capital A does is just epsilon. What capital B does is just epsilon. So A plus B. And you are going to get A plus B or A comma B. If you want to write a set, it's just A comma B. That's very simple, very simple. Yeah. The fifth one. S derives AA or BB, and A derives A or epsilon, B derives BB. Okay. I'm just looking at the answers, how you are going to try this grammar. When you look at bottom to up, first production, when you look at what B does, can it generate even one string? Oh, you already written answer? No, right? How did you get epsilon? How did you get A plus? Where are you looking at? Is there any recursion at all? First, AB, this BB is useless because it never stops. Useless. So that means B is useless. So this production is useless. B can't generate even one string, so useless. Now only you have one option, what A does. A does A or epsilon. So this A you can keep one option, otherwise epsilon you can keep there. So when you keep A, you get double A. When you keep epsilon, you get A. So double A or epsilon A. Epsilon A means A. That's all, only two strings, right? Only two strings you have. Double A or A. A you will get when you put epsilon. When you put A, you will get double A. Right? Only two strings, right? So these are the basic grammars. By this time, you should know exactly how to look at the grammar. Now we'll start the very important concept of the regular grammars. Okay, now first time I'm just helping you to understand the recursive grammar. This is the recursive grammar. What kind of recursive grammar it is? Previously they are not recursive. They might be left linear, they might be right linear, but they are not recursive. The first time we are looking at recursive grammar. What kind of recursive grammar it is? Of course, there are so many types of recursive grammars. But what type of recursive grammar it is? Left recursive. Even though it is left linear, because same non-terminal you are using at the first place, so we call it as left recursive grammar. And this left recursive grammar, when there is a recursion, remember, when there is a recursion, it generates infinite language. When there is no recursion, it cannot generate the infinite language. Okay, if you want to generate infinite number of strings, you must have the recursion inside. Maybe left recursion, maybe right recursion, or maybe any other recursion. So now this recursion, what kind of strings are going to generate? Anybody observed? It generates B first, directly next S you can put a B, so BA it does. Next you can repeat this twice, SA and S, again you write SA, so double A comes here. Before that you will be having B double A, and if you observe you will be having B 3As and so on. When you observe all the strings in lexicographical order, you will see a particular form. Is it BA star or BA plus? Okay, let's see. BA star or BA plus? When you say BA plus, right, you are saying A always comes. In that directly, can you see that? Without A, can I get a B directly? S can derive a B directly. Why are you restricting that A always comes? No, right? When you observe all of them, it simply is equal to B is definite, but A power 0, A power 1, A power 2, A power 3 and so on. So you can write A star. Okay. So this is a regular expression. In the exam, you do not know. They might give the question BA star. You need to identify the right grammar, or they may give you grammar. You need to identify the correct regular expression or regular language. Of course, you can also write it as a language. How? You can write as a language like B A power n such that n greater than or equal to 0. Okay, this is the language set notation. Another one is expression notation. Okay. Seventh. Okay, before that, so whenever you see this kind of recursion, so don't try all the strings. We have a shortcut also. What shortcut? So remember the shortcut. That shortcut is like, I'm keeping a note. Whenever you see non-terminal, that's, let's say, X derives X, and remaining everything is, let's say, alpha. It's a sequence of terminals, and beta is sequence of terminals. So what is your approach? Which one will repeat? Alpha or beta? This alpha will repeat. That's why you see A star in the result. And this beta is going to stop the recursion. So alpha star you write. If you don't have a beta, this never stops. So beta is must. So beta comes here. So how it comes? Because beta is a terminator and alpha is the repeator. So one is the repeator, other is a terminator. So repeator repeats any number of times, and terminator comes where you have the non-terminal. So X position. So you should be very careful what is the repeator and what is the terminator. So terminator always comes where that X is. If X is left, their terminator comes, or if X is right, then their terminator comes. Is that clear? So terminator position you should be keeping exactly where the non-terminal is. Is that before alpha star or after alpha star? You should be very careful. Done? So let's see another one. How will you answer it? S derives S, A, B and C, D, E. Okay. Now don't write all the strings. Just use the repeator and terminator concept. Who is repeator and who is terminator? So this AB is a repeator and terminator is a CDE. So what is the language? First repeator put in the star and the CDE should come left or right? Left. So you write CDE. That's it. CDE followed by AB star. That's it. No confusion where to write a CDE. Always look at exactly where the non-terminal is. Is that before or after AB star? Okay, by using this, you can easily answer it. I'm giving you to answer all these questions one by one, quickly. Okay, can you answer these questions quickly? Using the same concept, and don't spend much time because they are very easy. So what is the answer for the first one? Yeah, good. A star. That's all you can say, A star. If you don't see A star in the exam, just look at the any other expression that gives you A star. A star no need to write as A star. You can write many infinite equivalent answers. Right? A star whole square is also A star if you are aware of the previous practice. And this is A plus. There is at least one A should generate, then 2A's, 3A's, 4A's, all you can generate from here. And the 10th one, the double A repeats any number of times, so that is double A whole star. Epsilon no need to write because epsilon means zero symbols. When you put epsilon, you no need to, you will see A's only if A's are there along with epsilon. Okay, so don't worry about epsilon. When epsilon is there, put there. So epsilon followed by double A whole star is double A whole star only. Fine. Okay, this is with the left recursion. Let's go to the right recursion. That is S derives A, B, S or C. Okay. Now use the same concept. Use the same concept to answer. A, B, S or A, B. 13. A, B, S or A, S or epsilon. Very easy. You already answered, means it's very easy to answer now. Left recursion already answered. Use the same concept, but carefully put where the terminator should be. In grammar is computation, right? So programs also do computation. In the programs you have a logic, in the grammar also you have a logic. So programming language is a different model, grammar is a different model, right? So in any model, if there is a computation, there is a logic behind it. So that logic is needed for every kind of model. So it's not a programming language, but it is a kind of a model which computes something that you need to observe. Okay, grammars are different, programs are different, but both can do the same job if you want it. Okay, 11. Good. 11 is, so AB is going to repeat and the C is going to stop the recursion. So here repeator is AB star and C is the terminator. So this is the language. And what about this one? The AB is a repeator and terminator is also AB. So AB star followed by AB, which will be AB whole plus. Very easy. And A is the repeator and the terminator is epsilon. So A star followed by epsilon, simply A star. And here A star followed by A is A plus. Of course, you can write as A star A, or you can write as A star. Don't say that's a repeator, a terminator is coming left or right. So the meaning is going to be A plus, so you can write any direction, not an issue. Right? Final answer should be A plus. But repeator, if it is going to be matter like this one, C keeping at the last key, C keeping at the first, is changing the language, then you can't keep it. You have to keep it where it is needed. Okay. Renu Metal. You can search on Google my name, right? You will see anything that you want. Next, AA All Star. Done. So this is very interesting notation. If you see here, previous one that I write alpha is right side, alpha star right here. So I'll keep another note here, the similar one. Let's say this is a note 1. What is the note 2? Note 2 is, if you see that x derives alpha x or beta. Now alpha is left side, so alpha star, now beta should come right side. So this is a language. So whether it is left recursion or right recursion, use the same concept, because regular grammars, it's very easy to write the regular language, or representation of the regular grammar is very easy to write. Now let's go for more non-terminals. In all of them I have explained with a single non-terminal, right? Before going for more non-terminals, let's practice some of the examples too. 16, S derives, okay, with one non-terminal we'll try one more different one, SA or SB or C. Okay, this is another kind of example, but here you have two productions which are having left recursion. Now how you are going to understand the language? So don't try to write an expression now. First time you are looking at, right? When you look at the first time, understand what it does. And whatever you are going to write, now look at the answer and write that expression. Okay, most of the people directly answer it expression without understanding what strings. So strings are like C and CB, CA, and this thing should generate. So whatever you write, this string should be guaranteed. Remember that this string should be guaranteed. And if the minimum strings, these strings are not guaranteed, your answer is always wrong, right? So please try to keep an expression which generates. Oh, that is the problem. What you are trying to do, CA star, CB star, are they two different grammars or two different non-terminals? No, right? This can be repetitive. Now I can also write like, what is it? CAA I can write. CAB you can't generate now. The CAB is possible. How? S I can replace with SB, and S I can replace with SA, and S I can replace with C. See that? Now CAB you can't generate if you keep separately CA star, CB star. I did not give you two different things. Like if I give you S derives A or B, if A really does something like A or C, this is C A star. If B does what? The B or C. Now you say that CA star plus CB star, this does CA star, this does CB star. Oh, that I didn't give you. This R can be, right? Can be together. Then how you do that? This can be done. CBA can be done. CBB can be done. How you can do that? If you observe this, right? Apart from C always there. Apart from C, oh, A can be generated, B can be double A, B, BA, BB, epsilon. Everything is possible. If you observe this, it is C followed by A plus B whole star. Okay, that observation I want you to look at. That's why I asked you to write all the possible strings in order. Okay, this makes a special grammar together. What they do is together, it's not alone, it's going to be repetitive. When together they are going to come, it's going to be A plus B whole star. Okay, they are not individual. Even though I have done two different productions, but they can come in any order, in any sequence. That makes A plus B whole star, and C should come before, because C is there, S is there before A or before B. So here C should come. This makes C followed by A plus B whole star. Are you able to understand how you should write without looking at the strings? You can directly write from here what is language represented by this regular grammar. Okay, so what is the note for this? The note for this is, I'm also writing expressions. Remember, note for this is, suppose when you see X derives X alpha 1, let's say, or x alpha 2, and you have, let's say, terminator. Any number of terminators is fine, just one terminator I am helping first. So what is going to be your language? Your language is alpha 1 or alpha 2. This 2 can be repeated any number of times in any sequence. So that's how you write, and beta should come before alpha 1 or alpha 2 whole star. Okay, you can always follow this. No tree is required for especially regular grammar. This is the shortcut. Why do you want a tree? Did I do any tree here? I'm explaining first how to understand, because first time you are looking at, if you already know it directly, you write the answer, right? Why do you want this? Right, Sima? You never go for writing the strings. First time you are learning, you should know why we are following this shortcut, because without understanding, please don't ever write the shortcuts. You will forget tomorrow only. Okay, if you are not able to, if you are able to remember, it's fine, but I'm helping you why you should follow this shortcut. Okay, parse tree. Why do you want a parse tree? Do you require anything here? No, right? Fine. Let's see one more. 17. S derives SA or SB or SC or D or E or F or G. How you do it now? Do you really need any parse tree? No, right? Now we'll follow the principle shortcut that I have given you. What I have given to you? It's A or B or C. So these three can be repetitive in any order because they're all left recursive terms. And this can come, any one of them can come to stop the recursion. These four are terminators and these three are repeaters. These repeaters come in any sequence. So we write A plus B plus C whole star. Out of these three, anybody can come in any order, so whole star. And out of these four, anyone can come to stop or can appear as a terminator. So that will write just D or E or F or G. That's it. D or E or F or G. That's done. This is your language. Yes, Tanuj was right. So don't put a star here. This is not going to be repeater. It's just stopper, terminator. And how easy it if you know that concept. If you try to understand by writing the strings right, it may take much time. Yes, Isha. When you feel it is very hard because you are not focusing, or you are not giving the time to understand, or you don't want to learn many things, why you feel very hard. It's not about TOC, it's about any subject in the world. It's you are feeling hard means either you are not interested, or you don't have the person to guide you well, or you are not putting an effort. It could be any one of them, right? Why for some people it is so easy, why for some people it is so hard? Because it depends on how you study the subject or how you follow it. So all depends on you, whether you can make, whether you want to make it hard or you want to make it easy. It's in your hand, right? We are all just teachers, or we are guiding you to learn in right manner. So unless you are not following regularly, then definitely it feels very hard. So you are following step by step, and reaching even 1000 steps also starts with the first step. So if you don't know how to make the first step and how to go to the second step, then definitely you will stop somewhere. Even you jump directly to the third step, you will fall down directly. The TOC name itself, it is a new, right? Theory of computation, computation never ends. So put always the restriction, what you want to learn. Don't try to look at here and there. When you go for multiple places, multiple people will teach multiple ways, and it looks different completely. So follow one person blindly and learn everything from him, then definitely you will understand the subject. Okay, but learn from the experts always. That is my suggestion. 18. Now very important, SA or SB or epsilon. If you know this, see, I'm not at all confusing anybody, right? When I'm helping you any topic, I always start with the definition. I give very simple examples, then we'll go little bit medium problems, then harder. So we always go step by step. We don't go directly to the gate question and solve it and don't understand the definition and again come back to the basics. We never do that. We always go step by step, and when you reach end, you should be in a position to solve any gate question by yourself. So at least 90% of the question should be solved when you understand the pattern. Okay, good. So everybody has a different meaning. In the exam, they may ask you what is the meaning of the language also. If they don't give an expression, they will give you meaning. Yeah. First one, oh, it is a plus b whole star. Before that epsilon comes. So answer is going to be a plus b whole star. If I don't give you that rule or formation, you may take much time to understand sometimes. Now it's going to be very easy for you to write what is the language. It's a plus b whole star, epsilon no need to write before, and here this is going to be a plus b whole star. Before that ab comes, so a plus b followed by a plus b whole star. So this can be written as a plus b whole plus directly. So do not surprise by looking at a plus b whole plus. This is the right answer. Okay, that can be written infinite ways, and one of the ways here, that's exactly how the grammar is represented. Now this one, a plus b whole star is there, but that a is going to be terminator that comes before this because s is there before a or b. So here a is there. That means starts with a language. In the exam, they may ask you which of the following grammar represents starts with a. So this grammar represents starts with a. Okay, so you should be look at carefully why this is starts with a. And when you look at this grammar should start with b. Every string should start with b in the language. So this is starting with b. So by this time you should know how to write a grammar when the language is starting with a, when the language is starting with b. Similarly, ending with also we can write grammars, but we'll look at a lot of examples, then you will know how to write it. Okay, how easy when you know the concept. Okay, S derives AS, BS or epsilon. Now I am writing right recursion. So can you do it yourself? Yeah. I'm only using one non-terminal, but in the exam they may use a lot of non-terminals, then go always from bottom to up. So the answer is going to come in seconds. The reason is you understood how to write or represent a language. If you do not have that kind of shortcut, really it may take a minute or even more, maybe more sometimes. Now you can say what language is going to represent, what grammar is going to represent what kind of language. This one is a plus b whole star. I don't need to write everything because I know what is going to happen. Here it's going to happen a plus b whole plus at the end, that you can represent directly now. Because now no need to write a plus b whole star followed by a plus b. These all things you can keep in mind and write an answer directly. And this one, a plus b whole star, a plus b whole star, at the end a is going to come. Because s is there right side. So it's going to be ends with a, ends with a. And the next one ends with 3 consecutive ways. Because that triple a is going to come at the end. Right? Come on. 24, why a is coming front, Mamta? It should be end because s is there, end. Previously that s was there, begin. So now this concept you should be very careful that s is there right. So that terminator should come at right only. Okay, ends with a, not starts with a. Okay, always look at where is the s, where to put the terminator, always focus on that. Don't blindly write an expression. Okay, that's why I did not mention where is the s. I was looking at how people are going to write. When I mention it, you will follow it, but when I don't mention it, whether you follow or not, that I was checking actually. Okay, now let's see how you are going to answer this question. Okay, what is your target? Doesn't matter what is given, how big it is, just follow bottom to up. Slowly you will get to know what is going to be your answer. So always go bottom to up, slowly solve one by one, slowly solve. Don't look at here and there. If you start from here, you will never understand what's going to happen. So start from here, first focus on this and conclude what is the B, and focus on this, conclude what is A, then focus on this, conclude what is S. Because the regular grammar, when the grammar is regular, answer is going to be very simple. Remember that, answer is going to be very simple. Okay, so I'll give you 1 or 2 minutes, so answer this question, and this is going to be the highest level of the practice. So all were basics, and this is actually where you face the difficulty. So when you know the concept, these things should be easy when you do step by step, but do one at a time. What is B, what is A, then what is S. S is going to be your final language. No, Tanuj, this is what I am expecting, and you should be very careful. Why did you answer A followed by A plus B? Is it single A? Can you produce single A from here? Oh, you can, but is that? Oh, looks like you might be right. Single A. Oh, let's check. I did not simplify. Tanuj says starts with A. Is it really starts with A? I was actually writing different one, but why did I conclude that? Okay, so I went some wrong direction. Anyhow, so some answer might come. What Tanuj might be right, but I was expecting different answer because I have it in different grammar. That's why it was not my answer. Yeah, looks like Tanuj might be right. Anyhow, doesn't matter what grammar it is. Just simplify it. Whatever the answer comes, keep it. I was actually expecting for the third symbol from ending is A, but somehow I concluded a different one because of one small mistake. Anybody else? The A followed by A plus B whole star, is that the answer that you get? Is really starting with A all the time? Okay, let's look into it. This one is very clear. It's A plus B whole star. A is going to come, so whatever it does is going to be A followed by A plus B whole star. So now you got to know what is the B is. B is nothing but A followed by A plus B whole star. Oh, so everybody getting the same, so you might be correct. And what is A is going to be capital B, already you got, so keep that answer as it is. And capital B is going to be later we substitute. First this is also A plus B whole star before you have a B. So now B is actually already done, so put that A followed by A plus B whole star, again A plus B whole star. So you know A plus B whole star followed by A plus B whole star is just, you can write one A plus B whole star, that's fine. So A also we got the same. And now when you put this again, you have A plus B whole star and A is going to come first. So L is nothing but that S, L and S both are same here. So capital A dot A plus B whole star, and it is actually going to be starting with A only. Yeah, you're right. So my expectation went a different way. So the language is A followed by A plus B whole star. Let's give one more grammar, a different. Good. So you are so quick. Okay, you are so quick to answer this question because you know the approach. Okay, let's go for 27 to answer, because my focus went a different way. Let's do another thing. S derives AA or AB. B. At least I should not do the mistake now. Okay, let's leave it. A derives BA or BB. Fine. B derives CA. C derives CA or CB or epsilon. So this is what I was looking to write earlier, so that I did not made it. It should come something like, some specific position from the beginning or ending is particular symbol. Look at my options. One of the options going to appear like second symbol from beginning is A, or third symbol from ending is A, or the third symbol from beginning is A, or second symbol from ending is A. Some kind of options are there. When the options are there, right, you can easily answer it. But options are not provided. When it is provided, you will not have any difficulty. But after simplifying it, one of them should be the answer from the options provided to you. No answer it. Okay, check what C does. Everything. That's A plus B whole star. So whenever you want a C, put A plus B whole star. And B is very simple. It's not a recursive term. Remember, it's a B is C followed by A. C is already we know A plus B whole star and followed by A. C just substitute there. And what A? Oh, A is not a recursive. A depends on B. B already we know. So that's equal to, when you take a B common, it's A or B. And B already we know, that is A plus B whole star. A followed by A plus B. Okay. Just I'm taking the common to make it simple. Don't write everything. Okay. Now this one is the final goal, that is equal to A. When you take a common from both, you will have A plus B. Oh, A already we know. This is A. Put there directly. So what is that? A plus B whole star, A and A plus B. This is A followed by A plus B. So what is the meaning of this? The meaning of this is, now the language we got, that is A plus B whole star, A followed by A plus B square also you can write if you want, because 2 times A plus B came. So this is the last, and this is the second last, and this is the third last. So third from the end is going to be A, and before anything is right. So third symbol from ending is A. The language is nothing but set of all strings over A's and B's, where third symbol from end or from RHS is A, and sigma is of course A comma B. So this is what I was expecting in 26, but I have written wrong grammar, so got the different answer for you. Right, from the right side must be A. Everyone, so this is also a regular language, that's why you are able to write regular expression, you are able to write regular grammar. So these are the things are going to happen. Okay, so I'm going to give some easy questions for you. Okay, so comment after this, very easy questions I'll provide you, and please try to answer them in the comment section. So I've given a grammar, so it should be very simple and you should not take much time. Maybe now itself you can answer in the comment section. Okay, this is the first question I have given to you. And the second question, small changes in the grammar, right? If none of the answers is coming, definitely go for none. And also look at carefully, sometimes MSQs are there, then be careful and choose it. If 3 options are correct, then go for the 3. But I want equivalent language. And third question, and fourth question, that of course all the options are different. And the fifth question. So try them, try this. C is here small, don't assume it is a uppercase. So C is the terminal here. Fine. So try these 5 questions and see you tomorrow with a different topic in theory of computation. I hope you are learning, and then keep asking the doubts and keep posting your answers in the comment section in every video. So I'll be looking at. Okay. Thank you so much. See you tomorrow in the next session. Bye bye. Take care.